Okay, good afternoon. Now let's solve some exercises related to the chapter 8 for the conservation of momentum. Let's start now with the first one here. Consider there's a 6-kilogram fish that swims towards and swallows a 2-kilogram fish that is at rest. So the yellow fish is moving, okay, or is swimming, you can say, and its weight is 6 kilograms. And it's moving. And she swallowed a 2-kilogram fish, which is at rest. So here, her velocity is at rest. If the larger fish swims at 1 meter per second, so the velocity of the first one now is 1 meter per second. What is its velocity immediately after lunch? What does it mean? That means the big fish eat the small fish. So after that, we have now, after momentum, after collision, what did we have? We have the big fish, and inside here, we have a small fish. So after momentum now, we have the two masses that they are now the small inside the big one, and we have now a new velocity. We have to find this new velocity. So what do we have? We have to say it is 6 times 1 plus 2 times 0. This is before momentum, equal 6 plus 2, which is 8 times the new velocity. 6 equal 8v, so the new velocity will be 6 over 8 meter per second. And by logic, when it is 6, it's moving in 1 meter per second. When it is 8, when its mass increased, the velocity will be decreased. It will be lower while moving or swimming, less than the before it was 6 kilograms. Is it clear?
If we replace the velocity.
Sorry?
Yes, teacher. I say that if we make 8 times 6 over 8, it will be also equals 6. And this is the law of conservation.
Yeah, exactly. So this is now the solution here. The net momentum before equal the net momentum after, 6 times 1 plus 2 times, as we did before. So the velocity after lunch, it is 3 over 4 meter per second. This is for it. Now let's take another example here. Suppose now the small fish is not at rest, but it is swimming toward the large fish at 2 meter per second. So imagine now you have a big fish here. With 6 kilograms. So we have here a big fish with 6 kilograms, and it's moving with what's this velocity? 1. And her velocity is 1. And you know there's another fish, which is the small one here. It's like this. Okay, there's a fish. Okay, I don't know what's this. Imagine that is a fish. Now this fish here, her mass is 2 meter per second, and its velocity, it's not at rest as the previous one. It is swimming now toward the large fish. So when I say here toward the large fish, that means if the fish is going to the right, the left is going, the second fish or the small fish is going to the left. So because it's going toward it, So we say it has -2. The velocity will be negative. Okay? Here, it's going toward the small fish. So if we consider that this is the direction here of the movement, if she is, because she is going to the right with 1, and the small fish is going to the left with 2, but it's since the velocity is a vector quantity, it's need a direction. So I have to say that it's negative because it's going toward this fish. Is it clear why it's negative?
Yeah.
Yes, it's a right one.
Okay, now let's continue. So let's say here now we have 6. So before lunch, after lunch. Before lunch, we have 6 times 1 for the big fish, plus 2 times -1 for the small fish. After lunch, as we said before, we have both of them times the new velocity. So 6 minus 2 is 4 equals 8v. So the new velocity now, it will be ½ meter per second. This is the new velocity for both of them. Yes, miss.
If it was moving in the same direction, not toward, no, against, it would be positive, right? Because
Yes,
both are moving in the same direction.
yes.
Okay.
Teacher, but why is it 1? Why isn't it -2?
The one for the big fish.
Yeah, I mean, you said 6 multiplied by 1 plus 2 multiplied by -1. Why is
Okay,
it
okay, okay.
-1?
Okay, by mistake. Okay, I saw that -2. So here we have 6 plus -4, which is 2. Six minus 4, 2. So it will be 1/4 meter per second. So let's find here the answer. 6 times 1 plus 2 times -2. Okay, it will be the new after lunch, which is 6 plus 2 times the velocity after lunch. So the velocity after lunch here, it will be 1/4 meter per second.
Teacher, it does
Yes.
not necessary that the answer would be negative, right?
Yeah, negative, that's mean they are going towards, they are going to the opposite direction.
Okay. But like sometimes it will be like the answer will be negative. It's okay, right?
Oh, yes. Let's see this one here. Hi, this is your question here. Suppose the small fish swims at -4. The minus sign tell us that after lunch, the two fish system moves in a direction opposite to the large fish direction before lunch. Here we have the same. Okay, here by now, let's do it like this. So here, what did we have? We say that the net momentum before is the net momentum after. Now suppose that the small fish is not swimming at -2, it's swimming now at -4. And it's swimming very fast. What the direction that what is the velocity after momentum? What did we say? We say 6 times 1. This is for the big fish. Its mass is 6 times 1 plus the small fish. Its mass is 2, but now times -4. Okay, equals. Here we have equal by mistake. Okay, 6 plus 2 times the velocity after. Here we have So now, so 6 times 1 plus 2 times -4 equals 6 plus 2 times the velocity after. Then 6 times -8, which is -2 equal 8. So the new velocity now here, it will be -2 over 8, which is -1 over 4. This this negative sign rose, does it mean here that's the direction of the fish after lunch will be opposite her original direction, or before opposite her direction before lunch.
Teacher, when they say that it swims at -4, you might ask us, but in positive 4, and we should write it is negative, or you should tell us that it is negative.
Here in this question, they told you that it is the swim with -4.
Yeah.
With the previous one, they told you it's toward the small fish with 2. So you have to know that towards the small
Oh
fish,
yeah, like sometimes you not tell us it is
the
negative.
direction, she will be negative.
Okay.
Okay.
But sometimes you not tell us that it's negative. We should know it.
Yeah. So here, this negative sign, that's mean -1 over 4. That's mean. Imagine now the big fish is going to the right, and there's a small fish is going very, very fast to the left. She ate it. Oh, she ate it, you can say. After eating it, the small fish with the big fish, they are now with each other, but they will swim to the right with -1 over 4, with 1 over 4 to the to the left, sorry, to the opposite direction, I mean. Imagine it, okay? There's a big fish that's moving slowly. There's a small fish that's moving very fast. She eats it, but after she eats it, she will go to the opposite side because the small fish is very fast.
Yes, teacher.
Did you imagine it? Why it's negative?
Yes, teacher. Yeah.
So the small fish is negative.
Yeah, the small fish is negative. It's going toward the big fish and it is very fast. Imagine now you are walking, okay? You are walking on the garden as an example. And there's a girl in grade 1 or grade 2. She's moving very, very fast towards you. Okay, then she collide with you. After collision, what will happen? You will go to the right, you will go forward with her, or you will go backward with her.
No, forward.
How forward?
No, I mean for the fish backward, -1.
Yes. Not the you know. I mean here in this where's the pencil? This velocity here is for the big and for the small fish. Now she eat it. The small fish is inside the big fish. So both of them now are moving 1 over 4 or 0.25 meter per second to the backward.
Oh, okay. Yeah, I got it.
Okay.
Thank you, teacher.
You are welcome. Now let's solve this one here. Now, imagine now there's a ball of mass 3 kilograms is moving in a straight line at 32 centimeters per second. There's a ball of mass 3 kilograms moving, collided with another ball that is 2.5 kilogram that was at rest. So the first ball is moving, the second one is at rest, and they are collide with each other. determine the speed of this new body. So let's see here the graph here. What did we have? Here we have the orange ball, and there's a red ball. The orange ball, it has a mass and it's moving with v, which is 32 centimeters per second. Then the second ball now, it's at rest, so its velocity is 0 and its mass is 2.5. After collision, they are colliding with, they are sticking with each other, and they have a new velocity. So what is the velocity of the speed of the new body here after collision? What did we say? We say that here now, the momentum before equal the momentum after. So let's say here, we have m in oh sorry, I cannot write here. So m initial, v initial equal m final, v final. Now before collision, before momentum, what did we have? We have the first one, which is a 3 kilogram, times here velocity, which is 32, plus 2.5 times 0 equals. After momentum, what did we have? We have both of them now. They are sticking with each other. We have a new body. We have a new ball. So we have 2.5 plus 3 times. So let's say 3 times 32, 3 times 3 is 6, 96 equals 7.5 times the V final. So the V final here, it will be 96 over 7.5, which is 12.8 centimeter per second. So here the new speed for the two balls that they are moving now with each other is 12.8. Look at the velocity of the first one, it was 32. But because it's sticking with another one, so here we have a 12. Sorry, here as you see, the first ball, its mass is 3 kilogram. When it's moving now, or it's colliding now with another ball, her mass, their mass, it will be 5.5. Okay, why did I write 7.5? Here, sorry. Here we have 3 plus 2, 5.5, not 7.5. So here we have 5.5, okay? Not 7.5. So 96 over 5.5, you will find that it is 17 and 5 over 11. This is the new velocity. So since it was now a big ball, they are 5.5 kilogram, so by logic, their velocity will be decreased, which is 7 and 5 over 11. Is it clear now?
Yeah.
Yeah. Yes, teacher.
Okay. Do you have any question?
No.
Yeah, thank you.
This is how the questions for the conservation of momentum will be.